A galvanometer is an instrument used to show the direction and strength of the current passing through it. In a galvanometer, a coil placed in a magnetic field experiences a torque and hence get deflected when a current passing through it. The name is derived from the surname of Italian scientist L. Galvani, who in 1791 discovered that electric current makes a dead frog's leg jerk. A spring attached with the coil provides a counter torque. In equilibrium, the deflecting torque is balanced by the restoring torque of the spring, and we have NBA I is equal to K phi, where N is the number of turns in the coil, A is the area of the cross section, B is the magnetic field, and I is the current flowing through it, and K is the torsional constant of the spring, and phi is the angular deflection in the coil. As the current which produces full scale deflection in the galvanometer is very small, the galvanometer cannot as such be used to measure current in electric circuits. A small resistance called shunt of a suitable value is connected with the galvanometer to convert it into an emitter of desired range. By using a higher resistance, a galvanometer can be converted into a voltmeter. So question based on this paragraph. First one, the value of current sensitivity of a galvanometer is given by. देखो जो हमारे पास रिस्टोरिंग टॉर्क किसके बराबर, डिफ्लेक्टिंग टॉर्क के बराबर होती है इक्विलिब्रियम कंडीशन के ऊपर, तो ये बन जाएगा NBA इज इक्वल टू K phi. तो थोड़ा इसको रीअरेंज करते हैं, ये बन जाएगा NBA ओवर, अब हम क्या करेंगे K को नीचे ले आएंगे, दिस इज इक्वल टू phi ओवर I. तो हमारे पास phi ओवर I ये जो रेशियो है दिस इज नोन एज द करंट सेंसिटिविटी, और किसके बराबर हो गया NBA ओवर K. So here B is the correct option. Question number 2. A galvanometer of resistance 6 ohm shows full scale deflection for a current of 0.2 ampere. The value of shunt to be used with this galvanometer to convert it into an emitter of range 0 to 5 ampere is. In this question we have given galvanometer resistance, let it is Rg is equal to 6 ohm, and current flow through it is, that is Ig, this is equal to 0.2 ampere, and to make an emitter of range 0 to 5 ampere, that is I is equal to 5 ampere, and resistance of galvanometer, so let us suppose it is Rs. We know that when we convert a galvanometer into emitter, the shunt resistance is Rs is equal to Ig over I minus Ig multiply Rg. Here I is 0.2 and I is 5 minus Ig, that is 0.2 multiply 6. So this becomes 0.2 over 4.8 multiply 6. Now while solving this we are able to get the value of shunt resistance, and it is equal to 0.25 ohm. So in this way A is the correct option. Next question number 3. The value of resistance of the emitter in K second will be. We know that the resistance of emitter, this is equal to resistance of galvanometer multiply shunt resistance over resistance of galvanometer plus shunt resistance. Here in this question we are going to calculate resistance of an emitter. The resistance of galvanometer is 6 ohm and shunt resistance is 0.25. By putting the value of Rg and Rs in this equation, we get 6 multiply 0.25 over 6 plus 0.25. 25 6 the 150. So here 1.50 over 6.25. By solving this we are able to get the resistance of emitter, that is equal to 0.24 ohm. So in this question B option is the correct option. Next fourth question part A. A galvanometer is converted into a voltmeter of range 0 to V volt by connecting with it a resistance of R1. If R1 is replaced by R2, the rays becomes 0 to 2 volt. The resistance of the galvanometer is, we know that when we convert a galvanometer into voltmeter, we have to apply a large resistance in series, and that resistance is equal to V upon Ig minus a Rg. By rearranging this, take Rg to this side, we get R plus Rg is equal to V upon Ig. By rearranging this, the current through galvanometer is equal to V over R plus Rg. Here in this case, R is the resistance in series and Rg the galvanometer resistance. In first case, the resistance is R1 and range of voltmeter is V volt. So Ig is equal to V upon R1 plus Rg, because here R is equal to R1. In second case, when we replace R1 to R2 and the range becomes 2 volt, then Ig is equal to 2V over R2 plus Rg, and this is equation number 2. Now from equation 1 and 2, here equation 1 and 2, Ig is same, then right hand side also equal. So here V upon R1 plus Rg is equal to 2V upon R2 plus Rg. We cancel with each other, and we get here 2 is multiplied with the R1 plus Rg, and it is equal to R2 plus Rg. By solving this, 2R1 multiply with 2 inside, this becomes 2R1. 2Rg is equal to R2 plus Rg. Take Rg to the left hand side, 2Rg minus Rg, this is equal to R2, and take 2R1 to the right hand side, this becomes minus R2R1. So 2Rg minus Rg, that is Rg is equal to R2 minus 2R1. So in this way, in this question, A option is the correct option. Or part, a current of 5 milliampere flow through a galvanometer. Its coil has 100 turns, each of area of cross section 18 centimeter square, and is suspended in a magnetic field 0.20 Tesla. The deflecting torque acting on the coil will be. In this question, we have given current that is 5 milliampere. Now milli converted to, so 5 times multiply 10 raised to power minus 3 ampere, and number of turns is 100 turns. Area is 18 centimeter square. So now we are going to convert centimeter square to meter. Then we have to divide it with the 100 multiply 100. So this becomes 18 multiply 10 raised to power minus 4 meter square. Also magnetic field is given 0.20 Tesla. Here we are going to calculate torque. We know that torque is equal to NIAB. So here by putting the value of N 100, I 5 times 10 raised to power minus 3, and here area is 18 times 10 raised to power minus 4, and magnetic field 0.20, and this is equal to, by solving this we are able to get the solution. So and it becomes 1.8 into 10 raised to power minus 4 Newton meter. So in this way, in B part, B option is the correct option. The deflecting torque acting on the coil is 1.8 into 10 raised to power minus 4 Newton meter. Einstein explained photoelectric effect on the basis of Planck quantum theory, where light travel in the form of small bundle of energy called photons. The energy of each photon is h nu, where nu is the frequency of incident light and h is the Planck constant. The number of photons in a beam of light determines the intensity of incident light. A photon incident on a metal surface transfers its total energy h nu to a free electrons in the metal. A part of this energy is used in ejecting the electron from the metal and is called its work function. The rest of the energy is carried by the ejected electron as its kinetic energy. Now let us take the question based on this paragraph. First one, which of the following graphs shows the variation of photoelectric current with the intensity of light? As we know that the photoelectric current, it is directly proportional to the intensity of incident light. So the graph between intensity and photoelectric current is a straight line graph. So in this question, C is the correct option. Question number 2. When the frequency of incident light is increased without changing its intensity, the saturation current. We know that saturation current is independent on the frequency of incident light. It depends on the intensity of light. So saturation current remain the same because there is no effect on the saturation current if we change the frequency of incident light. Next, question number 3. Which of the following graph can be used to obtain the value of Planck constant? Here in this question, C option is the correct option. Cutoff potential, that is stopping potential versus frequency of incident light, gives the value of Planck constant. Next, question number 4. A part, red light, yellow light and blue light of the same intensity are incident on a metal surface successively. Kr, Ky and Kb represent the maximum kinetic energy of the photoelectrons respectively. Then in this question, C option is the correct option. Kinetic energy of blue light greater than kinetic energy of yellow light greater than kinetic energy of red light, because the frequency of blue light is greater than that of yellow light greater than that of red light. So that's why kinetic energy of blue colors greater than kinetic energy of yellow colors greater than kinetic energy of red colors. Next, OR part. Which of the following metal exhibits photoelectric effect with visible light? So in this question, A option is the correct option, cesium, because cesium are sensitive to visible light, and zinc, cadmium, magnesium only respond to ultraviolet light due to their higher work function.